Hello and welcome to this look at how to construct a balanced symbol equation from a word description of the reaction. So we'll use a question to work through and try and identify the key skills that we need as we go. So it wants you to write equations with state symbols for the following reactions, and obviously what they've done is describe the reaction, saying what reacts with what, and also say, as it says, what's made. So the key skills you need to think about is what state the element is in, using ion charges from your own knowledge to work out the formula, and then finally balancing the equation. So looking at the first one, magnesium is a metal, so your knowledge from GCSE would suggest that most metals, apart from mercury, would be solids at room temperature. Obviously nitrogen is a gas in the air, so you can put a G in brackets next to nitrogen. Magnesium nitride, this one's a little trickier, but it's a compound of a metal and a non-metal, so it's likely to be ionic. Ionic bonds are quite strong, meaning lots of energy is needed, or will be needed to break them, so it's likely to be a solid at room temperature. So we've worked out the state each element is in. So what we haven't done is work out the formula for magnesium nitride yet. Notice that I've put a 2 next to the nitrogen because nitrogen is a diatomic gas. That's a piece of knowledge you need from GCSE. So like hydrogen, H2, or oxygen, O2, or chlorine, Cl2, nitrogen is also diatomic. So magnesium is a group 2 metal, so we'll form 2+ ions. So nitride will be N3-. So let's think about why this is from first principles. If you take a nitrogen atom, it's got 5 electrons in its outer shell. It needs 3 more to complete the outer shell to make 8. So let's give it 3 electrons. Now it's taken on 3 negatively charged electrons, so this now makes it a nitride ion. It's no longer a nitrogen atom. So taking this idea, the lowest common multiple of 2+ for magnesium and 3- for nitride is 6. So the Mg2+ is multiplied by 3 and N3- must be multiplied by 2, which now means we've worked out the formula for a previously unknown compound. So finally we've got to balance the equation. Well, this one's quite easy. All you have to do is put a 3 in front of the magnesium. So what I'd like you to do at this point is to have a go at the second one. Pause the clip and see if you can get this one started using your ion charges list. Okay, welcome back. Let's have a look at how you did. So calcium is a metal, obviously, so therefore it's going to be a solid. Water is going to be a liquid, obviously, H2O with L next to it. And a solution of something is going to suggest or imply aqueous. So from your GCSE knowledge, we'd expect you to remember that hydrogen is a gas, so you put a G next to the hydrogen. So that means we've now worked out what state the element is in. So we need to look at calcium hydroxide. Calcium is a group 2 metal, just like magnesium, so it too will be 2+. The hydroxide ion is 1-. That's a piece of knowledge that you need to learn. So 2 of them will therefore balance 1 calcium 2+. So the formula of calcium hydroxide has to be adjusted to reflect this, remembering that the balancing of the charges is crucial. So CaOH2 is what we now put. So finally, we need to balance the equation. So checking the balancing on both sides, we need to double the water molecules on the left so that there are 4 hydrogens and 2 oxygens on the right, and we need 4 hydrogens and 2 oxygens on the left. So now we've balanced the equation. So I'm going to pass it back to you again. Pause the clip again. This one's a bit trickier, but have a go at it, see how much you can get done, and if you get stuck, you can start the clip again. Okay, welcome back once more. Let's take you through where the state symbols came from. How do we work that out? So, sodium hydroxide solution is aqueous. Iron 3 sulfate solution is aqueous. A precipitate, if you remember, precipitates are solids that are formed when two aqueous solutions react with each other. You may have done a practical, for example, on making precipitates, so may be familiar with the word precipitate. And sodium sulfate solution is obviously aqueous. So we worked out the states that something is in. Now the problem we've got is that we now have to work out the formulae. So an extra piece of processing that's present here is iron 3 sulfate. So the 3 means it will be a charge of 3 plus. Sulfate from your ions list will be SO4 2 minus. Sodium is Na plus because it's a group 1 metal. So that means we can build iron 3 sulfate as Fe2SO43. 3 sulfates is going to be minus 6. 2 iron 3 pluses are going to be plus 6. And similarly for hydroxide, you'll need 3 minus hydroxide, like minus 1 times 3, to match the plus 3 of the iron. At the same time, sulfate being SO4 2 minus needs 2 sodium 1 pluses to come up with Na2SO4. So finally, we're going to balance the equation. Now I'd suggest starting with the most complex formula and working outwards from there. So it doesn't matter which of the elements or species in the formula you start with. I'm going to start with iron. So 2 irons means FeOH3 needs doubling. So what effect does that have? That means we have 6 OHs on the right hand side. So to balance that, you have to put a 6 in front of the NaOH. Now what this does is it creates a third problem. That is that the sodium on the right hand side is not balanced. So we need to multiply the sodium sulfate by 3 in order to make 6 sodiums on the right. And that is our final balanced equation with the correct state symbols. So just taking these and checking them against the mark scheme, we can see that we're in the right place for both marks in each case. Okay, thanks for listening. Until next time, see you soon.